creating fractions and looking for equivalent fractions. So again, the tools I'm using are Matthews. This time I'm using the pattern blocks. So the first part of the task asks you to represent either a half or a third. And most that I saw that got a chance to start this activity were easily able to make a half or a half, oops, or a half. And even this one represents half, but then it comes into how do you communicate? How do you prove to me that that's half? That was part of the explain piece. So we remember that we have 1/2 and 2/2 make a whole, and that our denominators have to be equal sizes. So you could say to me that there's one red, and you know the second red one, or trapezoid, would make one whole. Therefore, you're showing 1/2. Same here, 2 green triangles would make a whole, so this is half. This is where it gets trickier, is how do you prove that this is a half? Many of you can do it with triangles, and I'm going to leave that explanation to you. I've watched all of you do it, so how many triangles are there, and how many have you shown? The other way, again, there's always more than one way to communicate. Could you prove to me that it's half because of this visual, and showing that if this was the odd shape, or whatever we call this, a red and a green and a red and a green, were the denominator, then you could do it that way. Okay. Sorry, I was trying something there. So as much as I will accept this communication to an extent, it will be more mathematical to prove to me how many, because we want the denominator to be all equal pieces. So how many greens would fill this up, and that becomes your denominator. And we can see it's 3 from the red, 4, oh my goodness. So 3, this would make 6, 7, 8. So our denominator would be 8. And this, even though I'm not using all the green pieces, it's 1, 2, 3, 4. 4/8. And you could prove that again by layering the green over top. Okay, so when you are proving it, you do really want to show all equal denominators. And although visually this doesn't look like our half, we can prove it by filling it with the amount, and we know 4 is half of 8. So that's part 1, and it's just representing fractions with different wholes. So whether it's this big one, this, or the small diamond. Now part 2 asks us to look at equivalent fractions. So this time I've asked you to take one shape as your base, and I'm going to pick for this demo the yellow, just because I want you to challenge yourselves with a larger base. So I'm hoping that you will pick one of these large ones. And what fraction can I represent in multiple ways? So I have a half, and is there any other options that I can do? So part of proving that is the repeat of what we just talked about, that this is 1/2 because there is 2 reds fill the whole and there's only one showing. This is 3/6 because 6 greens will fill the whole, but there are only 3 showing. Or 6 equal pieces are divided from the whole and 3 are showing. So this is what is an equivalent fraction, written different ways, but has the same value. It would also go a long way to show me if there's something that doesn't work for your fraction and why. So I'm going to look at the diamond, and can I show halves? Well, in this case, I can't. I can visually see that it's more than half, so that would be one explanation. I know that 2 of these blues are larger than a red. It also, I could say that I know that the blues split into 3 equal pieces. So that means that that is my denominator is 3, and it's 2/3. 2/3 is larger than a half, and I know that from my fractions, from my number line. 2/3, 1/3, 2/3 is bigger than 1/2. So you can use all these pieces to support your communication, and that's why we can use the iPads to record our thinking or sticky notes.